Rail Up, the Future Mobility podcast with innovators and leaders of the ecosystem. Presented by Sebastian Sperker.
My guest today is Sam Bemment, co-founder of the UK rail tech company Universal Signalling. In this episode, we discuss the challenges of deploying ETCS on regional railways, the future of reopening local lines, and how innovative signaling technology could make rail safer, faster, and more affordable. From the legacy of the beaching cuts to the global potential of low-cost signaling. Join us for an insightful conversation with Sam live from Derby, UK. Hi Sam, and welcome to Rail Up. And as the audience know, we start always the same question like, Sam, do you see yourself more as an innovator or a leader?
Hello. Well, thanks for having me on, first of all. And what a difficult question to start off with. What if I don't see myself as either? I think I'm an accidental innovator and an accidental leader. But if I had to be one, I think I'd probably say an innovator rather than a leader.
Okay, great. Yeah, then let's start our journey. When we talk about increasing capacity, improving safety, and achieving interoperability across Europe through a single signaling standard, we talk about ETCS, the European Train Control System. And I think for the major main lines and international corridors, ETCS is widely seen as the future and key enabler of more efficient European railway network. And however, this picture looks quite different for many regional and secondary lines. The high investment costs, the lengthy implementation timelines, and the operational complexity can make ETCS difficult to justify, especially on lower density networks. But these regional lines remain critical because they connect a large share of freight customers to the rail network, provide essential mobility for passengers, and often represents actually the first and last mile of the railway system. So the actual question is how we can preserve and modernize these networks without burdening them with solutions designed for very different operation environment. So Sam, let's kick off. And the question is the current industry obsession with ETCS actually killing our regional railway networks?
So I think that's a very good kickoff question. We're getting in with the big question straight away. I like that. So first of all, I want to start by saying ETCS. It's a fantastic initiative. It's been going many years. I think the original spec was 92, 93, something like that, and it's really brought together a lot of the manufacturers, our operators, infrastructure owners to a common vision of interoperability. Interoperability as an end goal is very noble. It's a good idea. In theory, it should bring costs down. But I think we have to bear in mind as well that ETCS isn't just a new signaling system, it's a complete new way of operations for a lot of railways. So we're moving what was a traditional line side signaling system, lights on sticks is the joke we always say, lights on sticks at the side of the line, drivers looking out the window, to a whole new way of working operationally where everything's relayed in the cab. So it's not just a technology change program, it's an industry change program, an operational change program. And I think a lot of the rural lines, and that this is perhaps copied in some countries in Europe more than others, but I can speak with the UK at the forefront of my mind. That's where most of my knowledge and experience comes from. There's some of these smaller rural lines where simply the budget, the business case will never be there to fully change the operations of those lines to something new. It just won't be there. Some of those lines have held on over the last 30, 40, 50 years. In fact, since we had the beaching cuts in the UK with barely enough money or subsidy to survive. So the idea that we need to go through a large industry change program for what I regard as marginal at best benefit on mainline and probably a net negative on these lines just doesn't wash. And now we've reached a point, especially in the UK, where we're probably at the most funding constrained stage that I've experienced in my time in rail. And I think that is copied in overseas jurisdictions. So we've really got to be making a strong case for making such a big operational change on those lines. So I think the word killing is quite provocative, but I don't see a situation where those lines would ever be truly interoperable and adopting ETCS.
Yeah, but can you just give us a feeling in your experience, why is the cost for ETCS so extremely high? And is there like a golden plate components that makes it affordable for smaller lines?
I think there's probably two main factors at play. So I don't know about gold-plated components, but I think you've got a system, first of all, a system which has a very long design life cycle, and it's a system that was almost engineered to be in its final state. So it's got a fantastic final state. Everybody's using ETCS. There's no signals by the line side. We've just got our point machines. Great. That's a great state to be in. But the path to get there is long, complex, difficult. There's lots of interactions, lots of interdependencies. So that particular aspect of the system, it is difficult to get it rolled out. And I think any project that lasts longer than a typical political cycle, so in the UK we have 5-year election cycles, and other countries, down to 4 or 3 years. Any project that lasts longer than that, if a politician decides to fund something in their first year and it's not done by the last year, it's not going to be their legacy. So, by design, by engineering and architecting a system which takes longer than 5 years to roll out, means necessarily the next jurisdiction, the next politician, the next government gets in and they want to tweak the system to their benefit, so they get a bit of a credit. And we all know what happens when project scope changes, costs rise, complexity rises, you end up with delays. Um, so I think the dream of ETCS is good, and I think some countries have done a very good job at saying this is the direction we're going, we're going to do it quickly, we're going to do it efficiently and getting it in. Others, such as the UK, have lagged behind that curve a little bit, and perhaps we have a slightly different railway to some of those in Europe. Very mixed traffic, many different operators on the same line, a lot of mixed freight traffic that make all of those factors kind of compound and even worse than it would be in other jurisdictions. But I can't name one gold-plated component. I think it's more the general architecture and the operational change that's being proposed.
But you mentioned just before like a beaching, and this refers like to rigid beaching, and where the famous cuts, where basically thousands of stations and miles were closed because of the missing profitability of these lines. But is it like even provocative to say that ETCS is a kind of a beaching cut? Because if you cannot justify an upgrade of the regional or the secondary network with ETCS, which is the plan, then at the end of the day, you having a big risk that you losing this network, this first and last mile for rail and this for freight and passengers. Isn't that the risk at the end of the day?
I think you're exactly right. And I think in coming years and perhaps decades, railways are very long term, right? But in the coming years and decades, we might start to see perhaps the road lobby and other transport modes saying, hey, why are you proposing to spend billions of pounds taking away those coloured lights and putting digital signalling in when you could have self-driving cars or more electric buses, for example? And all of the societal studies show that rail offers more benefits than electric cars or buses, more permanence, more increase in property prices, more access, permanent access to services, etc. There's loads of studies out there that show rail's real benefits, but if the particular politician of the day is faced with a choice between being forced down an ETCS pathway that's almost unaffordable or providing a replacement bus service, just as Dr. Beeching proposed to do, then there's only one way they're going to go. And there's only one way they can go. They've kind of had their hand forced in that direction.
Okay. And how does the rigid specification of ETCS act as a barrier to innovation rather than an enabler?
The specification of ETCS itself isn't particularly rigid. There are places you can innovate, do things slightly differently. I think what ETCS should have specified is all of the interfaces and let the individual suppliers come up with their own subsystems, whereas actually what it sought to do was specify the subsystems and leave the interfaces up to the suppliers, which is how you end up in the mess of, if you procure from supplier A, you need to almost get a whole system from supplier A, and supplier B can't even sell an individual subsystem into that because it's kind of signed off as a whole thing. So whilst the specification is loose, that the barrier there is that the interfaces weren't well defined, and that kind of makes it that you have to purchase from a single supplier. There is an initiative which we are big supporters of here at Universal Signalling called ULinks or EU Links. I've heard it pronounced both ways. And that is now to specify the interfaces. So coming up with specific ways for example, a point object controller, an axle counter, evaluator unit to communicate with a central interlocking. And the idea is to open up the market more. I'm firmly of the belief that that sort of approach should have been included in the original ETCS specs, but not forgetting what ETCS managed to do, which was to create a specification for a cross-border train protection system that has been widely adopted and has been incredibly successful, if at huge cost and time.
And actually, I would like to connect this to your personal story. In our earlier conversations, you mentioned that you were personally affected by the beaching cuts, Would it be fair to say that you experienced some of the consequences firsthand, given that you come from a village where the local railway line was eventually closed?
That's correct. Yes. So I grew up in a small town in Lancashire. Grew up in a town called Helmshire, and we were without a rail connection. I didn't ride on my first train until I was about 17. I think we went out to the seaside at Blackpool, and the line that was closed as part of beaching actually ran at almost not quite the bottom of my garden, but within 100 meters of it, and it was reopened as a preserved steam railway, the East Lancs Railway. So I was familiar with, trains, rail travel from the fact that you could go and get a £2 ticket on a Sunday and go up and down powered by steam or coal, but not the benefits that rail can bring. And it was only really when I went to university in Loughborough, where I grew up in Rosendale, I was perhaps 15, I guess 20 miles from the centre of Manchester, one of the largest growing urban conurbations in the UK. But getting there was a pain. There was a motorway which was always jammed up in the morning. I didn't own a car until I was quite old. And then there was a regular bus service, but that used the same motorway, so that was always delayed and jammed up. Went to uni in Loughborough, and Loughborough is 110 miles away from London, but I could be there in an hour or an hour and 10 minutes, I think it was. And I was like, hang on a minute, how does this work? Right into the center of the city in an hour and 10 minutes. And all of a sudden, that kind of realization of a completely grid separated transport mode that goes at 125 miles an hour straight into the center of cities. What a great idea.
You have spent a significant part of your career inside the rail industry, both in the supply sector and in the academia. So I'm curious, what was the particular moment or experience that made you realize the system wasn't going to change from within? What was the breaking point for you?
I don't think there was a particular breaking point, but I think you described my kind of work history quite well there. I've sat both sides of the fence, so I've done two stints at Network Rail, the UK's infrastructure owner custodian. I've done some consultancy and yeah, done a lot of R&D stuff. But I think my real eye opener was when I worked for the Railway Industry Association down in London. So that's the trade association for suppliers into the UK suppliers into the rail industry, wherever that be worldwide. Um, Great organisation. Look them up. They run a lot of events that are free to attend for people. So I'd very much recommend having a look at that. But the main observation was that I've already highlighted it in my earlier answer, but any project which is longer than a political cycle, and a political cycle doesn't have to be, the prime minister being in charge for 5, 10 years. It can be somebody moving through a role within a company who wants to get something done quickly to offer a bit of benefit, boost their career, or they're trying to fix a problem on their patch, that sort of thing. Any solution which takes longer than that cycle is almost doomed to fail because the benefits come too late. So really, in the past, I've worked on rail innovation projects, and the benefits were enormous. Like the cost benefit ratio was almost off the scale. But if they're going to take that long to deliver, there's almost no point starting. We're much better off doing small marginal projects that can deliver benefits really quickly and doing lots of them than going for the big price. Universal signalling is a bit of a similar approach in that it's not just about coming up with a new signaling architecture. It's about reducing the time it takes to deploy signaling down to days rather than decades. That's our tagline. Because if we can deliver those benefits really quickly, then obviously the client benefits, the passenger benefits, everybody's very happy with the new technology very quickly rather than having to wait 10 years for it.
Okay, actually, this was my question. Like, what was the philosophy behind founding Universal Signaling? That's your startup, but basically, I would sum it up to make signaling faster and smarter, right? So
Yeah.
that's more or less.
Yeah, it's very much about the speed. And I think that again, I quote UK numbers because that's where I've spent most of my career. It's around 83% of any signaling project, 83% of the cost of any signaling project is on labour, and about 17 is on equipment. So if I wanted to come up with a new signaling system and I just came up with some slightly cheaper equipment, the most money I can ever save the client is 17%. So I've still got the same labour on that. Whereas if I actually say, hey, my equipment's a bit cheaper, but really I've managed to half or quarter the amount of project overhead labour by reducing a 5-year project to, 6 weeks. We still need the engineers, we still need to be stuck in on the technical, but getting it done quickly, all of a sudden your opportunity for saving is 60, 70, 80%.
Yeah, and your mantra is actually signaling in days, not decays. And is that a literal promise or a provocative marketing slogan?
It's both. I think it is meant to be provocative. We started the company, and said, "Let's just sit down and think about how we can do things differently." Be unencumbered by current practice, like what is the optimum way of doing things. And when we really pared it back, we said, "Well, this is achievable in days. If you do things in a different order, you change the architecture slightly, we can do this in days, not in the decades." And but perhaps decades is a little bit, facetious. Not every small signaling renewal takes a decade. The big projects do, obviously, but not a small relock of a single junction or something. But you can you can measure the major projects in decades easily, and you can measure the projects we've done in days.
But then let's now we talked about that your approach for signaling is much more faster. Then let's have a deep dive into technology. So can you give us or explain your product and your new approach, in particular the UCROSS system being deployed in Wales in a for the non-technical listeners. So basically, what is your product and what you do different?
For the non-technical listener, perhaps non-railway listener who might tune in, signaling is the part of the railway that lets the trains move. It can intervene and stop the trains moving if they move too fast or too far, and then it directs them at junctions so they get to the right destination by moving the points, or switches, as you call them on the continent, and also does ancillary functions like operating level crossings to make sure the barriers come down before the train gets there, that sort of thing. The typical way that a signaling project works is that we decide we need some signaling. We decide we have a budget, and we don't know what the budget is. So we go out and we do a kind of an overview design and get a rough idea of what a particular project might cost. We then go for an authority to spend the money, and then we get into detailed design and we do lots of detailed design, come up with lots of options. And the thing about the railway is, whilst it is lots of uh, almost not interconnected systems, you very quickly find that actually a minor change, over there in Birmingham changes all the train timings all the way up to Derby and causes chaos on the rest of the network. So actually just saying, "Hey, I'm going to resignal this bit of line," becomes a massive sort of cross-disciplinary project with loads of stakeholders who all need to be consulted, and right down to, yeah, it's mind-boggling how sort of interdependent everything is. And then once we've got a design that's approved and signed off, we need loads of weekend positions and we go and build it. If it's greenfield and we're building a new railway, that's obviously a lot easier than doing a resignaling on an existing railway where you have to keep closing the line. And then once we've installed all the bits, we have some probably the most important people in any signaling project, the testers and verifiers, who go out and prove against the designs that everything is exactly as designed, so that when we switch it on the next day, there's no risk of putting a train into the back of another train, or worse, for example. And that's why it takes a very long time. And that process has developed over many years with different accidents, kind of bringing in new rules around certain controls, either in a project or a technological sense. And I don't want anybody going away from this podcast thinking there's anything wrong with that process. It's perfectly good. It has done us very well throughout the world for, since Victorian times. And there's a lot of very smart people doing a lot of very smart things. And the problem with it is that doing a design, installing it and testing it, and making sure that install and test meets your design, is very time consuming and very expensive.
Can you just give us a feeling like how long it takes to have a signaling in front of a U-cross? I mean, is it do we talk about years,
I can
months?
do I can do an example. So there's an item called a Euro Belize. So if you're doing ETCS, you have a Belize, and a Belize is like an RF. It's a fancy RFID tag in the track that the train can read, and it gets some data. Um, for want of a better way. You can buy one of those off the shelf from a number of suppliers. If you went to, I won't name a supplier specifically on this podcast, but I know that they're about £2,000 to £3,000 as a unit. So you can go and I can buy one from a catalogue for £2,000 or £3,000. But the actual cost of the design, test, installation, and then sending several people out to verify that you've put that Belize in exactly the right place according to the design, in recent UK projects is around £25,000. So it's a factor of 10. It's a factor of 10 nearly to put a Belize out on track because of the way we do design, and then we go and put the Belize out. Now, if you come to our products, so our first product to market is called Ucross, and you've already alluded to that being rolled out in Wales end of last year and throughout this year. Um, our products are based on beacons, so they are an RFID thing that sits in the track and the train can read just like a Eurobelize. It uses a slightly different frequency and different method of communication, but for the sake of this argument, it's the same thing. We just call them beacons because it's not an ETCS thing, and a Belize is an ETCS thing. So our beacons off the shelf are a lot cheaper than a Euro Belize, probably a factor of 100. So 20 to 30 pounds for one unit.
That sounds affordable.
So yeah, very affordable. And
Yeah.
because they're so affordable, we put them everywhere. So where ETCS has, a Belize or a Belize group every several kilometers, or where they need a specific safety function, which comes from the design, you work out where your Belizes are going to go through years of all of those design options. We've managed to make beacons so cheap and just mass manufacturable. Just stick them down everywhere, and if you want one of them to have a particular function, we can deal with that afterwards in software because we know where it is. So we don't design where our beacons go. We go out and we get a night shift, get a possession, and we go down and we stick a beacon, depending on what function we're providing, between every 5 and 30 meters. And there's no design. We just show up at site. We have a big box of beacons. We have a method of attachment, and we walk down the site and we go beacon, 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 beacon. And as we put them in, we record where the beacons are. So we are creating an as-built drawing with the unique code in the beacon at a unique location using a GPS RTK receiver accurate to within 20 millimeters. So there's no verifier needs to go out and tell us that the beacon's been put in the right place because we recorded exactly where we put it when we put it in. So on paper, you say, oh, a universal signaling beacon is £30, but they might fit, let's say, 100 of them every kilometer. So that's actually £3,000 a kilometre, and that's the same as a Eurobelize because you'd put one of those every kilometre, and they're about £3,000. But a Eurobelize isn't £3,000; it's £25,000, and we are fully fitted at the £3,000 per kilometre. So straight away there is a 90% saving on just by changing the idea of how you deploy things, not necessarily the technology.
How we can envision like this beacon? This is like a small box with the size of, I don't know, 10 centimeters length and 2 centimeters height, or
Yes, correct. Yeah, roughly. So they're about 20 centimeters wide, about 15 millimeters tall, and they just stick to the center of sleepers. And we can either screw, nail, hammer fix, or bond them, depending what the particular infrastructure owner prefers and what the track engineer prefers at that point.
okay. So and then basically instead of have one Eurobelize, you have plenty of your beacons. So it's more accurate, I have to say, right? Because like you
Correct.
have it
Yes.
every
Yeah.
30 meters, and like 10 times lower at the cost at the Eurobelize. But as you said, which is quite interesting, but the Eurobelize at itself is super expensive. Just really to test it, to get it there, to get it certified. I think that's the major cost there. And this you do completely different.
There is another factor at play here, which is the redundancy as well. So if you have a Euro Belize, you need to engineer it to work all the time because the system is absolutely dependent on that Belize working for the system to work. And actually, if under the ETCS standards, if a train misses a certain number of, and I don't know the number off the top of my head, sorry, but it misses a certain number of Belize reads, it will bring itself to a standstill and cause an operational, if not a safety issue. Could be the Belize reader is broken, for example, or the Belizes are missing, or there's other things failed. Whereas with the universal signaling way of doing things, we've used off-the-shelf cheap components. We anticipate over time our beacons will fail, but that's absolutely fine because there's so many of them that even if 3 or 4 next to each other fail, we've still got a train reporting its position to within 100 meters, say, which is way better than we can get at the moment with track circuits or axle counters. So unlike an ETCS Belize, we have a lovely degradation curve over time, which enables the infrastructure owner to plot the renewal of the system on a condition-based basis. And that's built into the system and the architecture in a way that ETCS doesn't have.
And you just told me like that you just recently equipped 11 miles of track in just 2.5 overnight shifts. So basically you getting really fast. But next to the G6, but that's just one side of the coin, right? Because that's the beacons, but you also need like a device who can read the beacons, right? And this must be obviously on the train, on the locomotive or whatever. Can you just tell us like how the other side is working?
Yeah, exactly right. So the Ucross product you mentioned is all around giving signallers better information about where trains are with regards to user work crossings. So in the UK, we've got about 2,000 user work crossings, and that's a crossing where there's gates that the user themselves must operate to cross. And in order to get permission for those gates to open, the crossing user must ring the signaller and say, "Hello, I'd like to use this crossing." The problem we have is that a lot of these rural lines have very long block sections with no train detection. So the signaller actually has no idea where the train is, and they must make the user wait if there's a train in that section. And some of the sections are up to 45 minutes, which is a real problem at harvest time for the farmers. They've rented a combine harvester by the hour, rented, paying a person to operate it, and they're sat there at the gates. And there might be a train 40 minutes away, but they're not allowed to cross. So the beacons are just one component. There are two other components. We've got a screen in the signal box which delivers information directly to the signaller and also readers placed on the trains. So the screen in the signal box just has a list of the crossings and time on approach of a train, and the signaller can then make a decision based as it rules in the UK, and I know it's different overseas around time of approach. You need longer for a large lorry or a combine harvester to cross than just one person with a car. So the signaller can make a decision based upon the information presented of exactly when the train will arrive. The trains themselves are fitted with reader units, so these are we can read from a beacon from 3-4 meters away. So the units don't have to be placed underneath the trains like they do with the ETCS spec. So again, one of the many issues with ETCS rollout is getting the trains fitted, especially with fleets moving around and trains not spending a huge amount of time in depots to be pulled to pieces and have new things put in the cabs. So if we come up with a train-based train detection system, but if we went down the same trap of requiring a big invasive cab fitment, it would never get rolled out. So what we've done instead is miniaturized and made our components low power, and we've actually managed to fit them all in a box small enough that you can clip it onto the front of any train in service, and it's got a battery in it that will last from depot to depot. So the beacon reader are train-based boxes. They can be clipped on in the depot in the morning. They've got a safety processor in them. They've got a beacon reader in them. They've got a multi-channel comms unit that will soon be able to use satellite communications as well as terrestrial communications. And for all the time the train is out on the network, that box will chirp back every time it gets a beacon read and say, "I am here, I am here, I am here." Which, if the train is going over, 3-4 beacons a second, that's a very accurate location of that train down the line to be able to give the signaller's terminal a position to report to the signaller.
The box is basically then communicating with your system, and you can like remote say, okay, like beacon number 1835 is now a red light, so please, and whenever you approaching this, you will see immediately in the box, or like how the box is communicating with the train driver.
Okay, so for the Ucross product, which is our first product, the driver doesn't even know the system is running. So it's just the boxes reporting back a position for the signaller to use. We have a full product roadmap to move from there. So, for instance, the boxes are equipped with uh, safety interfaces, so we could trigger the brakes if we wanted to. That's already built in there. We're just not using it as part of this project. And then further down the line, you're right. Yes, we'd give out movement authorities based upon beacons. We know where the beacons are. We know the distance between them from where we put them in. So yeah, the in cab screen could be different based upon different jurisdictions. And we don't propose to make our own in cab screen. We're already talking to a manufacturer of in cab screens that actually make parts for ETCS. What do you know? But in some jurisdictions, they've already got in-cab signalling. So, for instance, up in Scotland, we've had RETB, radio electronic token block, and there's a little we've had that since the 80s. There's a little screen that tells you've got the token to the next token exchange point. So really, it's in-cab signalling, digital in-cab signalling that's 40, 50 years old. There's no point putting an ETCS screen in those trains. If we ever upgrade the RETB to our system, the drivers and the operations people, like they almost don't need to know. Like those screens are great. They're perfectly functional. Why would you change that to a whole new system and need all of the training? Whereas if you go to a jurisdiction where ETCS is very heavily deployed. There's been a lot of training on it, but there's just these one or two other lines that are still based on color light signals. It's much more likely to be given the information in an ETCS-like fashion.
Just a little provocative. You have your lunchbox in the morning and you put it kind of like in the locomotive, which is then reading the beacons for this and communicating with the signaling. But later on, you can also use this box, maybe in an advanced mode, also to integrate this in the locomotive. And what you also told me that for the train integrity, you have like two boxes, one at the beginning and the one at the end. So basically, you always know if your train is formation is completed, or you hopefully don't lose any wing.
I mean, there's a lot to unpack here. So train integrity as a principle comes about because we don't have constant train detection. So we only need to know that the train, if the train comes into two pieces, it's going to stop anyway because the brakes will trigger because it will split the brake pipe. But knowing where the front and back of it is difficult because of the way we have long blocks, so we know it's in that block. Actually, if you have one of our boxes on the front and rear, we call it track occupation. So we always know exactly which bit of track to within 10 meters or so is occupied by the train, the front and the rear. And that leads to a lot of knock-on benefits as well around junctions, because if you know exactly when the rear of the train has cleared a junction, you can move the switch faster. So there are capacity benefits from that. And in terms of our little boxes and their capabilities, so we can permanently fit trains. We've permanently fitted one light rail vehicle to date, and we're looking at fitting 6 more heavy rail vehicles in the near future. It's a relatively simple and non-invasive fit compared to an ETCS fitment. So we just need an antenna on the underside and a space about the size of a shoebox with a couple of amps power supply to run our system. Antenna on the roof, or we can piggyback off existing comms. The train's already Wi-Fi enabled. So a permanent vehicle fitment for the sort of things we are proposing now isn't anywhere as near as invasive, and we'd probably do it in a couple of overnight shifts, just in the depot. As you get onto more future benefits and future systems, there will, of course, be a more invasive fit, just as ETCS has suffered from putting bits in the cabs. But I think there's two things to highlight here. One is coming right back to my initial statement on benefits needing to be delivered within a cycle. So we can do this now. We can clip a box onto the front of a train, and tomorrow that train is visible to our system. Any train, great. So if you want to start using Ucross, you need beacons in the ground, and you need one of those boxes on the front of your train, and then and a screen in the signal box, and then you can use it. There's no, messing around. And another thing with vehicle fitment, and one of the things that's holding ETCS up is purely the business case. We have a lot of older trains in the UK. The longer it takes to roll out ETCS, those trains are coming towards the end of their lease, towards the end of their life. Do you really want to be spending that amount of money to fit a train with an ETCS cab fitment that could be scrapped in 3, 5, 7 years? Well, actually, with our system, if you've got a temporary box that you can stick on the front, a temporary box in the cab, and a temporary brake interface, that train can have in-cab signaling for the remainder of its life. And when you scrap it, you can remove those components and put them on another train at minimal cost. So it's the life cycle elements of the product that we're quite proud of, I think, when compared to alternatives.
Absolutely. And if you come to diesel engines, then you have obviously everywhere in Europe exactly the topic that you will not equip any more diesel engines with ETCS because it's too expensive to do it. We do see a huge of benefits, but now comes like whenever we're coming to new innovation and cool approaches to the killing argument. What about the safety levels, the safety integrity levels, and also the homologation and certification of this architecture of these new safety systems?
The safety integrity levels obviously decided early on with the client through a formal EN specified process, which we've been through for Ucross, and we will go through for future product iterations. Uh, it's not big, it's not scary, it's a very well trodden path, it's a very well established thing to do. It's been done thousands of times, as is proving that your hardware meets that requirement. We aren't really proposing anything new. That's the strange thing here. So if we start issuing movement authorities based on beacon to beacon gaps, that's just absolute block. That was invented in the 1830s, 1840s. It's just very small blocks, but it is just absolute blocks. So we're not coming up with new signaling principles. Belize's beacons, using those markers as permanent position fixes. The communications that we're using is well established in the industry already. It's used currently up to SIL 2 or like, and being pushed to SIL 4 in certain situations, communications back channel. So there's nothing in our product stack and tech stack. We've got some secret sauce, of course, but there's nothing in our tech stack that hasn't been implemented, at least in part, before by others and well proven, well trodden path.
I'm a little bit surprised so that you talk about SIL 4 then. So communication is like already there is an industry standard in the UK what you can already refer to it.
For Ucross, we are just using commercial mobile operators and MNOs. So we have a partnership with a company called Mobius Networks, and they offer network hopping SIMs that are high priority. They're used by other signaling manufacturers. I won't say who, but they are used in up to SIL 2 products at the moment throughout the UK. And they offer both a high priority and high availability way of using this traditional mobile network operators, and also with a layer of redundancy as well because they will hop between the different operators. We've had fantastic success with them. They've been really good. Our trials have just they've blown us away on just how good the connectivity is with a nice big puck aerial as well for a bit of gain. However, if you look further afield, so perhaps the far north of Scotland, and some places in the southern hemisphere, there is no mobile signal available, and then satellite communications becomes the obvious second choice. We've just been awarded a project working with the European Space Agency to build satellite communications into UCross, so we can start to offer it to those jurisdictions as well.
You talked about the UK, but let's talk about for one moment for the market dynamics and use cases. Where is the sweet spot for universal signaling? Is this strictly for regional lines, or is there a path to the mainland as well?
So technically, there would be nothing to stop us moving into larger. I mean, the company was founded based upon the fact that we saw that these rural lines were really under threat, and we thought we needed to do something in a signaling sense to keep them alive. That was the original birth of the idea. However, technically, there's nothing stopping us moving on to bigger, busier lines, and we've had inquiries from overseas, from both hemispheres of signaling projects looking at right up to metro type things. Again, technically, there's nothing stopping us doing that, and in fact, that would be a great thing to do. I think you come up against sort of the market strength of the incumbents at that point. So at the moment, we are playing in an area where there's not a huge margin to be made because these are lines without much cash. Okay, so a lot of your big traditional industry players wouldn't really want to bid for a project because by the time you've included your bid costs and all the rest of it, it's just not worth making a product for that line. Whereas I think if we came up against some of the larger suppliers with where we are at the moment, it might be tough to compete initially until we've got a bit of a name for ourselves. But I don't see any reason why, in 5 or so years, we couldn't be pushing for larger contracts on mainline installations.
Let me challenge you with a statistic. If we are talking about lines with a simple infrastructure, limited signaling, no electrification, low traffic volumes, we could be talking about, I don't know, 70% of the world's rail network. I mean, it's just a guess, but so is it fair to say that this isn't really a niche solution for regional railways? It's actually a potential solution for most of the world's railway then, enabling them to make a century scale leap into the digital operations without the cost of a conventional signal system. Is that a fair characterization?
Yeah, no, you're exactly right, and I don't actually know the if you quote 70%, I'll trust you. I don't know the fraction, but I
No,
think
me,
it's
me
easy.
neither. This was just like
Yeah, it's a yeah,
best
educated
guess.
guess, but yeah, I think that if you sit in an office in Derby here in the UK where we are based, it's very easy to. I can see from here. I've got a depot behind me. I've got a Midland Main Line. I've got the Birmingham line. I've got Alstom just over the way, the train factory. Um, Everything is very expensive, very advanced. All the lines are signaled. We don't have dark territory in the UK. It's very easy to get stuck in that bubble of, oh, we're up against ETCS, we're up against, we're trying to do something better and cheaper than that. But you're exactly right. If you look at a lot of jurisdictions in the world still running passenger traffic under warrant working or a development of it, or in some cases, taking possession for workers based upon a phone call and a milepost that might not be there anymore. It might have been missing for 50 years. So there's a huge opportunity overseas for developing those sort of systems to something, as you just said, which is a bit more up to date. And don't forget the leap from um, making a phone call every time you reach a milepost from the cab of the train to ask it to signal, or if you can go 2 more miles, to having that displayed in front of you, so you don't have to stop at the junction and waste all that diesel starting again. Is actually, there's a lot of margin and money to be made in those situations for both the operator and for a small, nimble supplier like us.
Yeah, that sounds like a plan. And basically, we know, and as you from your former job as well, like the industry in Europe at least is dominated by few massive tier one suppliers. But and do you see yourself with universal signalings as like the disruptor looking to replace them, or more rather than a partner?
I think much more partner. I think the rails it's a massive market worldwide. I don't see a situation within the near future where we are going to be competing for a contract to do the digital railway on the East Coast Main Line, such as is being done in the UK at the moment. I do see a situation where those tier ones don't have a low cost, fast to deploy product that might suit some developing economies, for example, and wishes to pair with us and rebrand and move into those markets. And in fact, we had already had a few discussions to that regard.
Okay. And actually, like before we come to the outlook, how you convince actually the risk averse regulator that cheaper doesn't mean less safe? Because I think that's the crucial point then.
Yeah, but I think the burden of proof isn't on us. I think the burden of proof is on the ETCS to suppliers to prove why more expensive is more safe, or maybe they should be adopting something else.
Uh,
But
but
no,
but
I know
actually,
exactly. I'm being a bit facetious, but I know exactly where you're coming from. If you assume a much cheaper car isn't quite as good in some way, for example, if you were to go out and just do an open market study. But I think for us, it's providing the minimum set of functions that a rural railway or that the railway might require without all of the onerous other parts of either the long complex rollout or safety functions that perhaps would never get used, operationally on those railways, and that's where the savings are. The core technology, the core principles we're using are all well established.
could you tell us a bit more about where the company stands today? How large is the team where you're currently deploying the technology, and what are the next steps in terms of commercial rollout, like what you said, like the U cross. And yeah, and finally, if there are also investors listening, are you currently looking for strategic partners or investments?
Yeah, yeah, for sure. So we were founded in 2022. It was myself, Stephen Head, who's now the CEO, and Nick Wright, who I actually did my PhD with back at Loughborough University. We were in the same group. And Nick is our CTO. We're based out of an office in Derby on the Railway Technical Centre, where many great rail innovations have come out in the past. I mean, the tilting train was developed here originally, SSI interlockings, also fast freight wagons, all sorts of things. There's now 7.4 full-time employees working for Universal Signalling, and we've got a few more hires lined up that will be joining us shortly. We've also got a few contractors that are either fully or partly retained for the things we're working on with various different specialities around approvals and assurance. We originally we were self-funded, and we founded the company playing with Lego railways off my kitchen table.
Oh,
We
so
kind
the Silicon Valley style, actually, right? So
Yeah, yeah,
start in the
exactly, and all
garage.
all of
Yeah.
the first system
Yeah.
demonstrations were kind of constructed and puzzled out in Lego on the table, like, "What if this happens? How do we do this junction? What happens here?" So it was a great fun time. We applied for a few grants. We got, either lucky or skilled, I don't know which way you wanna put it, but we got awarded a few grants through 2023, 2024, which kind of turbocharged our growth. And then we got a trial on Network Rail of our Ucross product late last year, um, which was for the 18 kilometers or 11 miles you've already mentioned, but it was a fixed term trial. So that ran out by Christmas last year. And we're now just moving forward in negotiations to roll that out for the whole line.
Yeah. Okay. And you're looking for investors still, or?
So we have been through one round of investment. We did a pre-seed round May last year, so about almost exactly a year ago, which was oversubscribed. So we had to turn some people away. We exceeded our targets. We're currently considering a seed raise next year. That'll be to really turbocharge the business, but details of the exact timings and valuation will be advertised in due course.
When you envision like 2030, it's not that far away, but and you successfully rolled out universal signaling, or you started across Europe and the UK. What actually does the regional railway look like then in 2030? Do you see we see a renaissance of these railways?
I think I would count it as a success for us if the passengers didn't notice any difference whatsoever, and the tickets were a bit cheaper, and there were more trains, and smaller rural lines where the business case didn't originally exist to reopen does get reopened. So I think the base case is that you're almost looking at an alternative future. I don't know what it would look like without low-cost signaling for rural lines, but I could envision it perhaps being that some lines have shut down, some towns have been cut off, some communities don't have the access to the hospitals or jobs, the things that they would have otherwise had. And I'd like to think that in our future, none of those things happen, and that the public are happily going about their lives without any idea what signaling's keeping their trains safe, and they can still go about their daily business and be happy doing so.
Well, Sam, I think those are wonderful closing words for our podcast episode. Thank you very much for sharing your insights and for introducing us to your approach to making regional railways safer, more efficient, and above all, of course, more affordable. It is really fascinating to see how digital technology can help to unlock this potential of lines that have often been overlooked over decades. And who knows, perhaps we can even start reversing some of the effects of the beaching era by making regional rail services available again, reconnecting communities, strengthen links for both for the passenger and for the freight. Yeah, and that's actually RailUp. That's exactly what is RailUp all about. To be passionate about connecting people, sharing ideas, and exploring innovation that can help us to build a stronger and more sustainable railway ecosystem for the future. Sam, thank you very much and greetings to the UK.
Thank you very much for having me along. It's been all my pleasure, I assure you. Thank you for the invite.
Which superhero do we need to avoid the climate disaster?
I think superheroes are an issue because it's almost believing like something superhuman or something godlike is going to come along and get us out of this mess we find ourselves in. I'm afraid it's not going to happen. So we don't need any superhero. We need a concerted effort from everybody involved, right across politics, engineering, society, you name it, to reduce the dependency on certain resources, and ensure a climate fit for future generations.
What's the takeaway from this episode?
One of my biggest key takeaways from this conversation is that in rail speed matters, not only on the tracks but also in project delivery. In a rapidly changing political and economic environment, infrastructure projects must be delivered faster than ever. While conventional signaling and ETCS upgrade projects often takes years to plan and to deploy, we heard about a new approach that aims to deliver safe and affordable signaling solutions in a matter of days, using low-cost devices, simple installation methods, and highly scalable architecture. This is important for regional and secondary lines where ETCS upgrades are often difficult to justify. We also discussed the long-term consequences of the beaching cuts and explored how new technology could help reverse this trend and potentially reopen regional railways again. The opportunity extends far beyond the UK. Much of the global rail network shares characteristics similar to the regional lines. This creates a massive opportunity to improve access to rail for both freight and passenger worldwide. And that's exactly what the RailUp podcast is all about, exploring innovative ideas and technologies to make the railway more accessible, efficient and sustainable for the future.
This podcast connects innovators and leaders worldwide to shape the future ecosystem of rail. Rail Up by Sebastian Sperker.